3.9 octet rule, cations, anions, and Lewis dot structure. First, we are going to start with an overview of what we learned in the previous lesson. And in the last lesson, we learned about sorting elements based on chemical properties. The new things we learned were properties and locations of transition elements, representative elements, inner transition elements, alkaline and alkaline earth metals, halogens and noble gases. This is what we are going to learn today. And so let's review what we learned in the previous lesson in a slide. And I have provided you with a printout of this figure. So you should color it as such. And in purple is the D block or transition elements. And remember, mercury shown over here is the only, let me color it for you. This is a liquid at room temperature, correct? And everybody else is a solid. And this is a toxic element. And then F block starts in here. It starts right after the 5 and 6D subshells first electron fills. So we call it the inner transition metals because they fill inside the D block in 5 and 6D. And then we also know from 3.7 that boron, silicon, germanium, arsenic, antimony, tellurium, and polonium make up metalloids, which are elements that are in between the metals on this side and nonmetals on the right side. They have intermediate properties. And then we learned that there are alkali metals which are really reactive and they are soft and they are called alkali because they form bases when they react with water. And then we have alkaline earth metals shown in green. They are also soft but not as soft as these guys, and both of them, as you go down, they become softer. They have all the properties of metals, but they are generally very reactive. The group 1A is more reactive than 2A. And they are called alkali metals and alkaline earth metals. And they belong to S block. And then all of these guys are metals. And then we learnt about these guys where fluorine, chlorine, bromine, iodine, astatine, and tennessine, named after Tennessee, reside. They are called halogens. Halogens mean salts in Greek. They form salts with metals, especially these guys on S block. For example, you have sodium chloride, the famous table salt. And then we have the noble gases in group 8. Helium, neon, argon, krypton, xenon, rhenon, and I have a hard time pronouncing this, organicium or something like that. Anyway, today's lesson is going to be all about how every element strives to become like the nearest noble gas to attain a stable electron configuration by donating or gaining valence electrons to have a full set of valence electrons in their last shell. And so halogens and noble gases are nonmetals because they are on this side. And here are the electron configurations in the valence shell. We learned this before. And then alkaline earth metals have one more electron because they're in the second S column. Remember, when you know the block This is S block. The column number starting from the left tells you how many electrons. If you have 1 electron in S, you are here. 2 electrons, you are here. And in D block, the same thing. There are 10 columns, 3 to 12. If you have 1 electron, you're here, and here. If you have 2, you're here. 3, 4, 5, 6, 7, 8, 9, and 10 electrons. Then P, you have 6 possible electrons, 1, 2, 3, 4, 5, and 6 electrons. So let's look at halogens. They have 5 electrons in P, and all the S subshell is filled, as we talked about in the previous lesson. And then noble gases have 8 electrons, all except helium. So we are going to learn about a rule called the octet rule, where everybody wants to have noble gas / 8 electrons in their valence shell. And these guys are some of the representative elements. If you recall, group 1, 2, 13, 14, 15, 16, 17, and 18 are called group 1 to 8A because their valence electron numbers are the same as their A group number. Okay, now let's move on to today's topic. And here is the 3 things we're going to learn about: octet rule and ion formation. Cations and anions. You need to learn to figure out their oxidation number or their charge. They both mean the same thing. And then you need to learn how to draw Lewis dot structures of the valence electrons for only group 1 to 8A atoms and their ions. So let's look at the octet rule and ion formation. So what is the octet rule? The octet rule, if you break it down to 2 parts, says that all elements where they want to have a stable valence shell, they do this by either gaining or losing electrons and thereby forming ions to reach the nearest noble gas electron configuration. So because almost all noble gases except helium have 8 electrons with Ns2 and P6 general electron configuration, 2 plus 6 is 8. We call this the octet rule. Octet is 8. And this causes them to be very stable. Who doesn't want to be stable? So you must keep in mind that when atoms gain or lose electrons and form ions, the atom looks like the nearest noble gas only based on the valence electron configuration, not anything else. For example, if you take calcium, calcium gives 2 electrons. Calcium is over here. It gives the 2 valence electrons it has and becomes like argon. And just the valence shell. It has the same mass, same number of protons and neutrons like the neutral atom. The only thing different is that it has 2 less electrons than the parent atom, and it has a different ionic radius, like how wide the atom is going from the center to the edge of the perimeter. So let's look at the 2 types of ions. Just a funny reminder about cations. Cations are positive. Keep this in mind. You get cations and anions. So cations are formed, they're positive. That means you have a plus charge, meaning more protons in the atom than you had before. That means you've lost electrons. That's how you need to think about this. So these are formed by metals, basically, group 1 to 4A or elements. They're mostly metals, sometimes metalloids. They lose electrons. They have less electrons than protons. This gives them the net/total positive charge. Cations have the same electron configuration as the noble gas that comes before. So if you write the orbital notation or the noble gas notation or the full electron configuration, you cannot tell which element it is, because ions, you don't know what they are. You need to know the number of protons. That's what this means. And their ionic radius is smaller than the parent ion. And you need to remember that. So here's a figure of a sodium neutral atom. And when sodium gives up an electron, it becomes smaller, because now the nucleus can pull the remaining electrons closer to it. So it becomes smaller. So for example, here is strontium, and strontium assumes the nearest noble gas, which is krypton. So think about it. If strontium wants to become like xenon, it has to gain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 electrons. That's completely nuts when you can give up 1, 2 electrons and become like krypton. So atoms, when they become ions, they do the easiest possible thing: lose the least amount or gain the least amount of electrons to become like the nearest noble gas. So metals always like to become the noble gas in the period or row before them. Let's look at anions. So group 4 to 7A nonmetals and metalloid atoms form anions or negative ions by gaining electrons. If you gain more electrons, neutral atoms have zero charge because they have equal protons plus charge and equal numbers of electrons, the minus charge. So they have a zero charge. But if you gain more negatively charged electrons, you are going to have a total negative charge. This is why they are called anions. They have the same electron configuration as the noble gas that comes after them in the same period. So because they are located towards the right side of the periodic table, they're closer to the noble gas that comes after them than the noble gas before. So it's easier for them to gain a few electrons and get there. Their ionic radius is greater because now that you have more negative charge, the positive charged nucleus doesn't have that much of power to pull the valence shells closer to it because of electrostatic attractions between opposite charges, because you have a lot more electrons that neutralizes the positive charge. So these atoms have a larger nucleus, like I have shown here. Sorry, not a nucleus, an atomic radius or ionic radius. So if I say there is an atom and its ion, and the ion is larger than the neutral atom, you know this ion is a nonmetal or a metalloid that has gained electrons. And if I tell you there is an atom that becomes smaller in its ionic radius when it becomes an ion than a neutral atom, you need to know that I am talking about an atom that is a metal probably that lost electrons. So if you look at bismuth over here, if it gains 3 electrons, 1, 2, 3, it assumes the radon electron configuration. Second topic is about cations and anions and determining their charge or oxidation number. And I have given you a figure of this. Please paste it in your notes. So I have put the representative elements. You only need to know this for the representative elements. And here are your noble gases, some of them at least, and ions that these form cations because they are 1 to 4, and 4 to 7 can form anions. If you are wondering why group 4 forms either cations or anions, think about it. So if for you to get 4 electrons or lose 4 electrons is the same energy difference. So that's why. And let's look at the oxidation numbers. In the notes, if I put VE, I'm talking about valence electrons. So these guys, they give their 1 valence electrons away and make +1 ions. And these guys make +2, these guys make +3, and these guys make both +4 and -4. And then these guys make -3 because how many do you need to become 8? You need 8 minus 5, which is 3. When you gain 3 electrons, you get a -3 charge. And then if you have already 6 electrons, you gain 2 electrons and become a -2 charge. If you have 7 electrons like the halogens, you just need 1 more electron to be like the nearest noble gas, and you will gain 1 electron and get a -1 charge and do that. And noble gases, their oxidation number is 0 because they are stable and they don't form ions. And here's how to figure it out. These guys, cations, lose electrons and end up with a plus charge. The plus charge is equal to their valence electron number with a plus in the front. And let's look for anions. There, they gain electrons and their charge is equal to valence electron number. For example, 4 minus 8. 4 minus 8 is -4, right? And this guy, 5 minus 8 is -3. 6 minus 8 is -2. And 7 minus 8 is -1. And 8 minus 8 is 0. And then let's look at some examples of how to write ions. So, for example, sodium, lithium, hydrogen, and potassium would be written with just a plus sign. So in chemistry, if you have gained or lost just 1 electron, we don't write -1 and +1. We just write the plus. If you have more than 1, then we write the number and the sign. So if you lost 2 electrons, you make 2 plus ions. So Be, for example, would make Be 2 plus ions. You write this as a superscript. This top number is called a superscript. You must remember that. And then you do not write them at the same level. Aluminum, group 3 elements, make 3 plus ions. Group 4 makes 4 plus or 4 minus. I just wrote 4 plus. And 5 makes 3 minus. Group 6, sulfur, makes 2 minus. Chlorine, fluorine and bromine makes just minus. And these guys, we don't, if I ever ask you, write 0. Next off, let's figure out how to draw Lewis dot structures representing these elements. So when you draw Lewis dot structures, you just represent the valence electrons with dots. Each electron in the valence shell is shown as a dot. And you, for my chemistry course, only have to draw Lewis dot structures for group A elements. So you put a maximum of 2 dots on each side. For example, you can put, if you have 4 valence electrons, you are going to write, and say you're drawing carbon, you draw carbon like this, and you draw 1 dot here, and 1 dot here, and 1 dot here. You can, this is typically the way we draw it, but as long as you put dots in the corner, that's fine. On the 4 corners, like north, south, east, west. So such a structure is called a Lewis dot structure. And now let's look at this atom. So this is a group period 2 element, correct? It has 2 energy levels. So because this is the valence shell, we are only going to represent the elements on the valence shell. So say it has 1 electron. So then you write it like this. You write the element symbol for the Lewis dot structure followed by 1 electron on the 4 corners. You could put this electron on the top here, over here, or over here. It doesn't matter. So this particular atom would be represented by lithium. And what if you have 2 electrons? Then you will look like this. And you can put the second electron in any of the 4 corners. And in this case, this atom is showing beryllium. If you have another 1 electron, 3 total valence electrons, you will draw their Lewis dot structure as such. And in this case, we are showing boron. And if you have 4 electrons, you will look like this, as in my example before. 5 electrons, you will look like this. Again, you can put your 5 electrons in any way as long as they're in the 4 corners, 2 dots maximum for one side. And then if you have 6 electrons, you will show like this. In this example, we are showing oxygen. And then if you have 7 electrons, in this case, we are showing fluorine. You are just missing 1 electron, right? And if you have 8 valence electrons, you are looking like this. And helium only has 2 valence electrons, and it's completely filled because it can only have 2 maximum electrons. I need you to fill out the missing elements in the printout I have given you and paste it in your notes. This is the end of the content. Let's do some practice questions. I have given you a printout of this. Paste it in your notebook and answer the questions. If you are watching the video, pause right here and try to figure out the answers and then work it with me to check your correct and wrong answers. So, question 1. If A and B are the same atom, they're not isotopes. A is the parent atom and then B is A. I'm asking, is it a cation or an anion? So if A is the parent and B is smaller, this is definitely a positive charged ion, right? So it's going to be smaller if it's a cation. And in this example, if X and Y are the same atom, Y is the ion, then X is, in this case, the ion is larger. So this can only happen if you gain electrons. Then you are negatively charged and you're an anion. So Y is an anion. Question 3 is based on these unknown elements and their Lewis dot structures. So since all elements in A group have the same Lewis dot structure, you can't say anything about who they are and their masses and proton numbers based on the valence shell. You can only figure out about things about how reactive they are and which A group they are and which ions they make. So question 3 is asking which of these atoms belong to group 6A. Remember, your group A number is the same as your valence electron, so you will count and see who has 6 valence electrons. The answer is E. And then question 4 is asking which element makes -1 charged ions. -1 mean you gain 1 electron to become an octet, right? You must have 7 electrons then. So it is D. And question 5 is asking which element can either gain or lose electrons when they form ions. Who can gain or lose electrons? Somebody who has 4 electrons, right? So that would be Y. Number 6, which element has NS2 valence electron configurations? Somebody who has 2 electrons, the answer is X. Write the ion symbols for Y, D, E, and X. So Y would give 4 or gain 4. So you can write either +4 or -4 as superscript. And D will gain 1 electron and make a D minus. And E, since it has 6 electrons, will gain 2 and make a E2 minus ion. And X will donate its 2 electrons. This is a alkaline earth metal. It'll give up 2 electrons and make a +2 ion. And that's it. So here is our review. Group A, 8A noble gases have a full set of valence electrons and they're highly stable and they do not form ions. Other elements strive to have the same noble gas electron configuration. Octet rule states that elements gain or lose electrons and become ions to obtain a full set of valence electrons like the nearest noble gas. Cations are formed by metals in groups 1 to 4A who lose valence electrons to become like the noble gas that comes before them. Anions are formed when nonmetals 4A to 7A gain valence electrons to become like the noble gas that comes after them. Then group 4A elements can gain or lose 4 valence electrons when they form ions because gaining 4 or losing 4 is the same energy difference. Valence electrons of elements are shown as dots. It's generally anywhere from always 1 to 8 dots and 2 dots maximum per one side. So you are going to put dots in the north, south, east, west direction from the symbol of the element which is going to be in the middle. And each dot is representing a valence electrons. You only need to know the Lewis dot structures for groups 1 to 8A elements and ions. Then when we talk about ionic radii, cations have a smaller radius than the parent and anions have a larger radius than the parent. That's it for now. Please do the exit ticket. Thank you.